Hi, my name is Rohit Pasula, and this is my video for Lab 3, Magnetic Field of a Bar Magnet. The objective of the lab is essentially to observe and measure the distance dependence of the magnetic field due to a small bar magnet. We will compare the measurements to the distance dependence predicted by the equations derived from the Biot-Savart law. We will also create a computational model through a program called GlowScript and visualize the magnetic field around the bar magnet. The fundamental principle demonstrated throughout the lab is the Biot-Savart law and the distance dependence formula for magnetic fields. Before going through the procedure of the lab, there are a set of preparations that we must accomplish first. We prevent other electronic devices from being in their surroundings as they may affect the magnetic field, altering the data. Then we align the phone with the Earth's magnetic north and south axes. You can do this by rotating the phone until the x-axis nears 0. At the end of these preparations, the net magnetic field that appears on your phone should be similar to that of Atlanta's, of 49. Now, the procedure of the lab includes a meter stick. We set up the meter stick to be orthogonal to north as shown in the top image. Afterwards, we locate the magnetometer of the phone by sliding the phone perpendicular to the stick in the XY directions. Mark the axes with edges of tape. Lastly, we move the phone along the meter stick while measuring and recording the magnetic field components into the spreadsheet. The data recorded is on the sheet. The graph portrays a negative slope demonstrating the effect of distance on magnetic fields. The data recorded for the off-axis fields is also shown towards the bottom. Creating our computational code, we inputted the magnetic magnitude of the magnetic moment, which we calculated from our data. We created a function to determine the magnetic field. Afterwards, we created the vectors for the axis and perpendicular components. Finally, we demonstrated the distance and generated arrows to determine the magnetic field. So as you can see, the model generated is to the right. The model shown is a visual representation of the magnetic field generated by the bar magnet. The vectors listed are the magnitudes of the magnetic field in different directions. Our computed distance is 0.23 meters, and the magnetic field at 45 degrees at that distance was around 2.3 times 10 to the negative 3 in the x direction and 6.9 times 10 to the negative 3 in the y direction and 0 in the z direction. Now, there are some possible sources of error that may have occurred during the course of this experiment. One is that other electronic devices in my surroundings may have affected the results. Human error in measuring and recording the magnetic field components could have happened as well. Inaccuracy in orienting the experiment to compensate for magnetic north due to human error again is plausible too. So, for our reflection questions, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The magnetometer readings would have been skewed in the direction of Earth's magnetic north. The x component of the magnetic field would not be 0. Therefore, we would be analyzing not just the magnetic field of the bar magnet, but of the Earth as well. Now, what if you were to stick two identical magnets together, end to end, and run the experiment again? How would you expect your measurement to differ? The direction of the magnetic field would be the same. The magnitude of the magnetic field would essentially double. The two magnets together would basically act as one large magnet. Thank you for listening and have a great day.